Hi everyone. This time we're going to see another way to solve our system of three equations in three unknowns. Instead of using an augmented matrix this time, we're going to use matrix algebra. So we can write these equations in the following form. I could take the coefficients 2, 1, 1 for the first equation. Then the second equation coefficients are 1, 1, 1, 2, 2, 1, and write them as a 3 by 3 matrix. I could multiply them by the vector x, y, z. And using standard rules of matrix multiplication, that's equivalent to saying 2x plus y plus z as the first entry in the outcome vector. But we already know that that's 6 and then 4 and then 5. So this is rewriting our system of three equations in three unknowns as a matrix equation. 3 by 3, a lovely square matrix, which were the coefficients. It's important that my x, my y, and my z pronumerals were all in the same order. Then a vector here with my pronumerals, my unknowns, and then a vector here with the constants. Now, as we've seen before, if we want to solve this using, now I think we did 2 by 2s in the past, but the same technique exactly applies. We would multiply by the inverse if it exists. And remembering matrix multiplication is not commutative. So I've got the inverse multiplying there on the left-hand side, then I'd still have my x, my y, my z. And just like any other form of algebra, we do the same thing to both sides. And multiply by that constant vector 6, 4, 5. So if my inverse matrix exists, we're in business. Now, this is a situation where we would use our calculator, our technology. You would not be expected in an examination, at least under the school system that I work in, to find the inverse of a 3 by 3 matrix. Now, once you get to, beyond school, well, that's fair game, because there are certainly ways to find the inverse of a 3 by 3 matrix without technology, but we're not going to make you do that. So what will we do? Well, we'll just start by entering our 3 by 3 matrix, won't we? Which is 2, 1, 1, 1, 1, 1, 2, 2, 1, and I literally just write to the power of -1. Now, isn't that beautiful? It's a lovely straightforward result. So definitely I now know that the inverse of this matrix exists. I'm just going to move my calculator to the side there for a moment so you can go back to see my working. Now, because we know that exists, we can write down on our next step that a matrix multiplied by its inverse is, of course, the identity matrix. Still multiplied by this vector x, y, z. And now here's the bit where I'm going to write down the results of that, which my calculator gave me, which was 1, -1, 0. So I'm literally reading these from my calculator screen, 0, 1, and 0, 2, -1, multiplied by my constant vector 6, 4, 5. So, of course, the identity matrix multiplied by the vector x, y, z is just going to be the vector x, y, z. Now I'll have 1 times 6, -1 times 4, plus 0 times 5. Then I'll have -1 times 6, plus 0 times 4, plus 1 times 5, and lastly 0 times 6, plus 2 times 4, minus 1 times 5. So that gives me that x, y, z is 2, negative 1, 3, which is exactly the same solution we found last time, of course, because it's the same system of equations. So I've set that out in excruciating detail there for the purpose of explaining what's going on. If I were to be writing this on an examination, I would shorten my setting out in the following way. So I would certainly not want to take all that time. I would write it like this. I would go vector A by, matrix A by vector X equals vector B. And I would just make a quick note over here where matrix A was, now I better write that down for you, hadn't I? It was 2, 1, 1, 1, 1, 1, and if I remember, it was 2, 2, 1. Yep. X is our vector X, Y, Z, and B was our constants, which was 6, 4, 5. So that's what I'd be writing in an exam. Now, in order to save myself an awful lot of time, I would write this, and then I would use my technology, wouldn't I? Then I would write that the identity matrix by X equals, and this is pretty much where I would pick up from what I had over there. After my technology had done its job, I would probably then show just that little bit. Oh, it didn't go where I wanted. Oh, now I've ruined it. Trying to be clever there, but that didn't help, did it? Well, I think you get the idea. I would only show my working at the last bit. So I would have down here X, Y, Z. That's what I get for trying to be clever. And inverse of matrix A, I would write that down directly from my calculator screen, which was 1, negative 1, 0, negative 1, 0, 1, and 0, 2, negative 1. And then I'd write down those constants 6, 4, 5, and then I'd have X, Y, Z equals, what was it again? It was 2 minus 1, 3. So that's what I would say is the absolute barest minimum of setting out required. Yes, in an exam where time is crucial, go with that. When you're learning, it doesn't hurt to do a little bit more thorough setting out while you're learning and practicing and understanding the processes that are applying. Okay, thanks for watching. See you next time.